Welcome to a MyNotes tutoring video by Mr. Mkiza N. And today we are just going to look at the rules of differentiation. So this is the rule. If you are given a function f of x equals to a, where a is any particular constant. So if we look at this a, we are just referring to any particular constant, and then the question might be, how do you find your derivative? Well, you multiply that a that you had before, and you must multiply it with the n from the top. So this is the n that we are looking to, and if you then multiply these two, you must go back and subtract 1 from the exponent that you had in your function. So let's just say we have f of x equals to 2x to the power 2. So in this situation, what you want to do is to get your f prime of x, you must multiply this 2 at the top with the 2 that is the coefficient of x squared. So you'll have 2 multiplied by 2, x to the power 2 minus 1. So finally your f prime of x will be 4x to the power 1. And in mathematics we do not write this one, but it is enough for us to know that it is there. Then we can also look at a different situation. We can write this in black, and here let's say we have g of x equals to let's say 4x to the power 3 plus x. So what is happening in this case? Well, to get g prime of x, we must multiply these two numbers. So 3 multiplied by 4 will give us 12x, and then you say 3 minus 1, which will be 2. Then here, this is a different case, because for most learners this might be challenging, because here you have 1, but also in front of this x you also have an invisible 1. So you are multiplying 1 and 1, which means you will have 1. But what happens with this? Let us write it on the side here. So you have a case where you have x to the power 1 minus 1. So this becomes x to the power 0, and as you can remember, anything raised to power 0 is 1. So you are multiplying, in this case, 1 and 1, which will give you 1. So this ends up being your derivative. But in your rules, there is also an interesting case where if you are given f of x equals to k, and a k is a constant, which means it is just a number. So how do you deal with this situation? Well, the rule says the derivative of a constant is 0. So you must always remember that a derivative of just a number on its own with no variable is 0. So if I could say I'm giving you f of x equals to 2, then the derivative with respect to x will be 0. So this is the basic idea that we are looking at in these situations. So now let us look at some examples. So example 1, this is a case where you have multiple terms. So when you have multiple terms, you need to deal with each term individually. So there are 3 terms. We know we have 3 terms because terms are separated by a plus or a minus. So 1, 2, 3. Those are 3 terms. Now to get the derivative f prime of x, we will say 2 multiplied by 2. This will give us 4x, and then 2 minus 1 is just 1. And then we come to the second term with an invisible power 1, and that power 1 times 3 will be 3, and then x to the power 1 minus 1 is x to power 0, which means this will just be 3. And then the last term is just a number, and the derivative of just a number, a constant, is 0. So this will be our derivative with respect to x. The second example is when you have constants, but these constants are fractions. So if you look at the number in front of x squared, it's a half, a fraction. The number in front of x is 9/7, a fraction. And the constant is a fraction. So how do you deal with those cases? Well, you say f prime of x equals to, you must deal with each term each time. So you have 1/2 multiplied by 2. So this is half times 2, that will give you 1. And then you'll have x, and then 2 minus 1 is 1. So there's an invisible 1 that we got by multiplying half and 2 when we got 1. So that is the one that is here, and then 2 minus 1 will just give us 1. And when you have x to the power 1, this variable is going to disappear because we're going to have x to power 0, which is 1. So this will be 9/7. And then the derivative of a constant is 0. So if it is 0, there's no need to write the 0. We just leave it like that, and this will be our derivative. So if you move on to example 3, this is when you have a variable in the denominator, and the examiners love this problem because it gives challenges to learners. You have to do something before you find your derivative. So you must be careful here. You see, this is not the derivative, it's just f of x, because we still need to bring the variable in the numerator. So it's right now in the denominator, so we need to bring it up. So if you look here, you have 2x to the power 3. Remember, this is still f. And then how you do it is you bring x to the numerator, so x, but now your exponent will change, and the 1 is still here. The 1 that you had here is still here, but because it's in front of x, it's invisible. And then you minus 6x to the power minus 1, because at the bottom you had positive power 1, so now you'll have minus 1. And now you have 3 terms, and you can find your derivative. So you say f prime of x equals to 3 times 2 will give you 6. X, 3 minus 1 is 2. You come here, you say negative times positive is negative. 2 times 1 is 2. X minus 2 minus 1 would be minus 3. Negative and negative, positive. 1 times 6 is 6. X to the power minus 2, because we have minus 1, which is minus 2. Then in example 4 we are looking at problems where you have roots, and if you look here you have x to the power n and you have the mth root, so you want the mth root of x to the power n. So how you change this to exponential form is what was inside goes to the numerator and what was the root will go in the denominator. A simple example is if you have square roots of x, so this means you have x, you have 1 here, so it goes in the numerator, over, it's the square root, so there's an invisible 2 there, so it's over 2. You can also look at another example. Say if you have x cubed and you want the fourth root of x cubed, then this would be x, what was inside goes in the numerator, and the fourth root, so this is x to the power 3 over 4. So before you can find your derivative, you must deal with this root and this root. And what is this? Well, we'll deal with it accordingly. So remember, this is still f of x because we still need to get our house in order. So we'll have x. This is, remember there's a 2 since it's a square root. So let's go back. So you'll have 3 which will go on the top, and then the square roots, then the 2 will go here, plus x, what is inside will go on the top there, over 5 for the fifth root, and then minus pi, that is pi, which is the ratio of the circumference and the diameter of a circle. And what is important about pi is to remember that it is just a number. So we find our derivative, f prime of x will be 3 over 2 because you are multiplying it with 1. X 3 over 2 minus 1 will be 1 over 2. And then you have to then deal with this part, so you'll have 3 over 5 times 1, which will be 3 over 5 x, and then 3 over 5 minus 1, which is like minus 5 over 5 will be minus 2 over 5. And then what is the derivative of a number? Since we said pi is just a number, it's 0. So that is how you deal with pi. It's just a number. So what happens if you have a variable in the denominator? In fact, this is supposed to be a variable in the denominator, and we can actually try and fix that. So this is variable in the denominator, variable in the denominator. So how do we deal with that? Well, it's pretty straightforward. Firstly, you have f of x equals to, so this x is a common denominator, which means you must spread it back to each term. So 1, 2, 3, there are 3 terms, so you will write 2, you will write 2 pi x cubed over x squared, plus, which is this plus, this will be cube root of x all over x squared minus x to the minus 1 over x squared. So this will become 2 pi x cubed over x squared. This is a root. We were dealing with it before, so we know how to change it. This becomes x to the power 1 over 3 all over x squared minus x minus 1 over x squared. And now we have to apply the laws of exponents. So 2 pi will get back, and remember, when you are dividing, you take one base and subtract the exponent. So you have x 3 minus 2, which is 1, invisible 1, and then you have minus 1 over 3 minus 2, so you have 1 over 3 minus 2, which can be written as 6 over 3. So this becomes minus 5 over 3. So you can also just do that with your calculator. So you'll have x to the power minus 5 over 3 minus here you have x to the minus 1 minus 2, so that would be x to the power minus 3. And now you are ready to find your derivative. So f prime of x will be that 1 multiplied by 2 pi, it's 2 pi, and 1 minus 1 is 0, x to the power 0 is 1, plus here, if you look at this, you'll have minus 5 over 3, so in fact you'll have negative times positive, which is negative, and then you'll have 5 over 3 because it's times 1, x to the power, you can do what we did, minus 5 over 3 minus 1, which is 3 over 3, so that's minus 8 over 3 minus 8 over 3. Negative times negative will be positive. 3 times 1 is 3, x to the minus 4. So it requires a bit of work, but it's worth it. Then finally, we look at a case where we have a binomial, which means two terms. So we have a trinomial, and it's a quadratic expression in the numerator, and in the denominator we have a linear binomial. So how do you deal with this? Well, you can't find a derivative when you have your equation in this form, your function in this form, and also at the same time you can't just spread the x as you did, because there's a minus 3 as well. So this is an opportunity for you to factorize, and in almost all the cases this will be the first bracket or one of the brackets when you are factorizing, so that this will be cancelled with something in numerator and you'll be left with something. So if we go ahead and we try and factorize, so we must open two brackets. You'll have x, factors of 6 that are relevant is 3 and 2, minus and plus. So that is the situation we have at hand, x minus 3. So if you look here, in fact we were supposed to have minus there, so there's a minor problem that we can fix over there. So if you want to fix this problem, you are supposed to have a minus. So the technology is acting up right now. So we'll just write it in this way. So let's just write it in this way. So we are supposed to have a minus here, not a plus. So what will happen is this will cancel with this, and you are left with f of x equals to x plus 2. And now when you differentiate, you will find that you have 1 and 1, so that would be 1, and then 1 minus 1 is 0, so it's 1 times 1, and the derivative of a constant is 0, and that will be all.